Hello everyone. Today we will talk about the type of numbers and divisibility test. First, let us talk about integers. Here are some integers. The integers highlighted in blue, we learned them before as odd numbers. For those in red, 0, 2, 4, 6, 8, and 10, they are called even numbers. If we would like smaller numbers than these numbers, then we would have the negative numbers. For example, we have the negative even numbers and the negative odd numbers, like negative 2, negative 4, and negative 1 and negative 3. The number 0 is neither positive nor negative, so remember not to add any sign in front of 0. After a quick revision about the types of numbers, let's have another revision of the divisibility test of 2, 3, 5, and 10. For the divisibility test of 2, that means they are the multiples of 2. To find out the multiples of 2, I believe it is not difficult for everyone to know that this means they are even numbers. So that means for all numbers, if you look at just the last digit of any number, as long as they end with 2, 4, 6, 8, or 0, then they are even. For the divisibility test of 5 and 10, which means the multiples of 5 or 10, it is also the same as 2. We look at the last digit of these numbers. The multiples of 5 end with either 0 or 5. The multiples of 10 ends with 0. But what about the divisibility of 3? What about the multiples of 3? How do we find them? Here we have a really big number, 25,311. To perform a long division on this number and determine if there are any remainders, that is a very long process. Therefore, one way to do it is to add up all of the digits together. For example, in this particular case, the digits sum up to be 12. If this sum is a multiple of 3, that means the bigger number, 25,311, is definitely also a multiple of 3, meaning it can be divided by 3. Now, let's learn about the divisibility of 4, 6, 8, and 9. The principle is the same as previous numbers, turning large and big numbers into smaller numbers, so it's easier to analyze. Let's first talk about the divisibility test of 9. It's actually very similar to the divisibility test of 3. We first sum up each of these digits together, and now that forms 18. If this number is indeed the multiple of 9, then we can be very sure that the number in front, 81,036, is indeed the multiple of 9, so it can be divided by 9. For the divisibility test of 6, it is a very special kind of number, because 6 equals to 2 times 3, meaning it is at the same time a multiple of 2, an even number, and also a multiple of 3. Satisfying these two would satisfy the divisibility test of 6. Let us look at 71,502. Just by looking at its unit, we can see that it is an even number, as it ends with number 2. To check the divisibility of 3, we add up all of the digits together, which is 15, and 15 is indeed a multiple of 3. Since it is an even number and it is a multiple of 3, therefore we can deduce that 71,502 is indeed a multiple of 6. For the divisibility of 4, the number 4 is actually in very close relation to the number 100. This is because 100 is divisible by 4. Let us look at this example, 95,412. First, let us split it into 95,400 plus 12. The part in front, 95,400, is the same as having 954 $100 bills. And since 100 can be divided by 4, we can just ignore this part and only put our focus on the part at the back. And now, since 12 is indeed divisible by 4, therefore we can deduce that the number in front, 95,412, this number is also a multiple of 4. In short, this means we only need to check the last 2 digits of any number to see if it is divisible by 4. Anything in front of the last 2 digits can definitely be divided by 4. Let's practice some more. These are 3 very big numbers, but to check if it's divisible by 4, all we need to do is check the last 2 digits of each of these numbers. The last 2 digits are 12, 24, and 8. All 3 of these numbers are indeed multiples of 4. Therefore, each of these big numbers are all divisible by 4. Lastly, now let's go to the divisibility test of 8. 8 is related to 1,000. Same as 4, 1,000 is divisible by 8. We can use the same principle as the divisibility test of 4. Here is number 35,816, which we can split into 35,000 plus 816. The part in front, 35,000, is the same as having 35 pieces of $1,000 bills. And each of this $1,000 bill can be divided cleanly by 8, leaving 816. Meaning, when we check that 816 is a multiple of 8, like the divisibility test of 4, we can deduce that 35,816 is indeed a multiple of 8. This means to check the divisibility of 8, all we need to do is check the last 3 digits. If the last 3 digits are indeed a multiple of 8, then this number is indeed a multiple of 8. That's it for today's video. If there's anything you don't understand, don't hesitate to go to the math room and ask your teachers. Goodbye.